Hello dear students, in today's class we are going to see a new concept that is nothing but a zero divisor. Now a non-zero element A is said to be a zero divisor. Remember this definition holds in a commutative ring R. If we are having a non-commutative ring, definition is slightly different. So whenever we are in a commutative ring, and remember zero divisor is always a non-zero element. So a non-zero element of a commutative ring R is said to be a zero divisor if there is one more non-zero element of the ring, of the same commutative ring, such that the multiplication of that two elements is equal to 0. So this non-zero element A of a commutative ring R is said to be a zero divisor, will be a zero divisor if we are able to find another non-zero element in the ring R, we are calling it as B, such that the multiplication AB is equal to 0. So in order to understand it, let us take an example. We have Z6, right? So Z6, the elements are 0 bar up to 5 bar. Now what are the non-zero elements of Z6? Because zero divisor is actually a non-zero element. So the non-zero element are 1 bar, 2 bar up to 5 bar. Now out of this, let us check which are the zero divisors. So we are checking whether 1 bar is a zero divisor or not. So what we want, the multiplication of 1 bar with some number of Z6 should be equal to what? 0. Remember, this 0 is actually the additive identity in our ring. So in this case, our additive identity is 0 bar. So one by one we will check. So if we put here 1 bar, then we will not get 0, right? What I am doing, we are putting different values of this element here so that we will get 0, right? And if we are able to get 0 for some non-zero element here, then that will prove that this 1 bar is a zero divisor. So the non-zero elements that we know are 1 bar, 2 bar, 3 bar, 4 bar and 5 bar. So 1 bar multiplied by 2 bar will be 2 bar, 1 bar multiplied by 3 bar will be 3 bar, 1 multiplied by 4 will be 4 bar and 1 multiplied by 5 will be 5 bar. So we do not get 0 here. So it means that 1 bar is not a zero divisor. Let us pick another element, that is 2 bar, and we have to check 2 bar multiplied by something is equal to 0 bar or not. Remember, this something is actually a non-zero element in a ring. So if I put 1 bar once again, we will get 2 bar, right? 2 bar multiplied by 1 bar will be 2 bar. If you put 2 bar here, it will be 4 bar. If you put 3 bar here, it will be 6 bar. But note, we are in Z6, and in Z6, 6 bar is nothing but 0 bar. So 2 bar multiplied by this 3 bar is actually equal to 0 bar. This implies 2 bar is a zero divisor. Similarly, we can see that 3 bar multiplied by 2 bar is also equal to 0 bar. So it also indicates that 3 bar is also a zero divisor. Similarly, we can check for other elements. Let us say if I take 4 bar now, so 4 bar multiplied by what is equal to 0 bar, that is what we have to check. So 4 bar multiplied by 2 bar is 8 bar, 4 bar multiplied by 3 bar is again 12 bar, and 12 bar is actually nothing but what? 0 bar in Z6. So this also implies 4 bar is a zero divisor. Okay, in Z6, remember. Now similarly, what about 5 bar? So if I take 5 bar multiplied by what is equal to 0 bar, that is what we have to check. So the possibilities are, we have to put 1 bar up to 5 bar here. So 5 multiplied by 1 will be 5, 5 multiplied by 2 will be 10, 5 multiplied by 3 will be 15, 5 multiplied by 4 will be 20, 5 multiplied by 5 will be 25. We do not get 0 bar Thus 5 bar is also not a 0 divisor in Z6. So what are the only 0 divisors of Z6? That is 2 bar, 3 bar and 4 bar. So indirectly what we have proved, thus 2 bar, 3 bar and 4 bar are 0 divisors of Z6.